Welcome to The Explainer. Today, we're going to decode the secret language of computers. We're breaking down how everything you see and do on a screen is built from a super simple but really elegant sequence of just two numbers, 1 and 0. So let's start with a little puzzle. How can a machine that basically only understands on and off create everything we see? I mean, from a quick text message to a huge blockbuster movie. You'd think it's impossible, right? Well, the answer is surprisingly clever. It all comes down to a powerful and, incredibly simple language called binary. This is the secret code that our entire digital world is built on, and it's made of just two little symbols. So at its core, binary is just a way of counting that perfectly lines up with a computer's electronic circuits. Every single transistor inside a processor is either on or off. That's it. And these two states get their own numbers, 1 for on and 0 for off. Simple as a light switch. You know, the system we use every day, that's called decimal, or base 10. We've got 10 digits to work with, 0 through 9. And where you put a digit changes its value. You've got the ones place, the tens place, the hundreds, all powers of 10. Computers, on the other hand, use a base 2 system. They only have 2 digits, and their place values are all powers of 2. All right, so how does this actually work? Let's really get into it and see how computers use this simple system to represent numbers, which is the first step to building, well, everything else. So when you see a binary number like 1011, it's super easy to look at that and think 1011. But hold on. In the computer's language, it means something totally different. Let's break down an example to really see it in practice. Okay, so this table really breaks it down for us. In binary, you read from right to left with each spot being a power of 2. You have the ones place, then the 2s, the 4s, and the 8s. So for 1011, we've got 1 8, 0 4s, 1 2, and 1 1. Add them all up and you get the number 11. And using this exact method, you can build any number you can imagine. Now, to keep things organized, computers don't just deal with single ones and zeros flying around. These individual digits are called bits, and computers group them into convenient little packages of 8. This group of 8 bits is called a byte, and honestly, it's one of the most fundamental units in all of digital information. Just wrap your head around that for a sec. With just 8 tiny little on or off switches, just one single byte, a computer can represent any whole number from 0 all the way up to 255. That's the real power of combining these simple little bits. Okay, so numbers are one thing, but what about words? How do we get from raw numbers to, say, the very words you're reading on this screen? Let's check out the next building block. Well, since computers only speak number, they need something like a secret decoder ring, right? A dictionary that translates those numbers into all the letters, symbols, and punctuation we use. And these dictionaries are called encoding schemes. And one of the OG dictionaries for this is called ASCII. It's a standard that basically gives a unique number to every single uppercase and lowercase letter in English, plus all the numbers and common symbols like a question mark or a space. And this is just a brilliant way to see it in action. If a computer wants to store the word cat, first it looks up each letter in that ASCII table. C is 67, A is 65, and T is 84. Simple enough. Then it takes each of those numbers and turns them into 8-bit binary. Finally, it just smushes them all together. That crazy long string of ones and zeros, that's cat to a computer. Now, ASCII was great, but it had a big problem. It was pretty much just for English. So today, our computers use a much, much bigger system called Unicode. It works on the exact same idea, but it has room for over 1 million characters. We're talking basically every language and symbol on the planet. All right, so we've got numbers, we've got text, but what about pictures? How on earth does a photo get turned into a bunch of ones and zeros? You can think of it like a giant, super detailed paint-by-numbers canvas. Every image is just broken down into millions of tiny dots called pixels. And for every single one of those pixels, the computer stores a numeric recipe for its color, usually with a system called RGB. So for each color, red, green, and blue, you get a value from 0 to 255, which tells the screen how much of that color to light up. Pure red is 255 red, 0 green, and 0 blue. And wait a second, 0 to 255. Does that number range sound familiar? It should. That's exactly the range a single byte can store. See how it all connects?
It's all built on the same foundation.
Okay, so let's pull back for a second and just look at the amazing big picture that's starting to form here. The most important thing to get from all of this is that every single piece of digital info you've ever seen or heard, numbers, text, images, even music and movies, is at the end of the day just a massive, massive collection of ones and zeros. And it all comes back to the physical machine. I mean, this system wasn't just picked out of a hat. It's a direct result of how electronics actually work. A circuit is either on or it's off, and this beautifully simple two-state system is what makes all of our modern computing possible.
So, when you really stop and think about it, our entire digital universe is built from an almost endless series of simple yes or no answers. Understanding this doesn't just demystify the tech we use every day, it empowers you to see the actual building blocks of the world we live in. Thanks for tuning in.